Hello everyone, let us start with our question. In this question, what is given? For a spherical symmetric charge distribution, variation of electric potential with distance from center is given as to be V equals to Q divided by 4 pi epsilon naught R naught for R less than R naught, and V equals Q divided by 4 pi epsilon R for R greater than equal to R naught, and this is the variation which has been shown. So for R equals to R naught, potential value is constant, and after R greater than R naught, it is decreasing with a, it is inversely proportional to R, so it is decreasing like this. Okay, now this could be a distribution for, it can be a distribution, can be a distribution, can be a distribution, it can be distribution for what? It can be distribution either for a shell or conducting sphere. Okay, conducting sphere. By the diagram we can see, because inside there is no potential, so the potential is zero, that means electric field, sorry, potential is constant, therefore electric field would be zero, so that means there is no charge inside this location. Okay, inside at R less than R naught. Okay, so it would be a case of either the shell or conducting sphere. Now we need to find which of the option is the correct. Now total charge within 2R R naught is given as R naught. So in the first part, in the first statement, it is given as for R equals to twice of radius. Okay, twice of radius R naught. The charge is Q. So is this right or wrong? So this statement is true. Why? Because if, for example, if this is our spherical shell, okay, if this is our spherical shell of radius R naught, the radius is R naught. Now if we are outside this shell, okay, at a distance of 2 R naught, so here it is given as to be, radial distance is given as to be 2 R naught. Okay, so whole charge would be inside this shell, so we can say that first statement is a true statement. That means it is correct. Now total electrostatic energy for R less than R naught is non-zero. Okay, that means inside this for R less than 2 R naught, sorry, inside this 2 R naught, it is not equal to 0. So in the second part, we know that electrostatic energy, basically we can say that potential energy would be equals to Q dot Q into dV, or the change in potential. Okay, multiplied by the change in potential. Let's say from the surface, we are moving from the surface up to a point at a radial distance R naught, so we can say that it would be Q. Then V at the surface, we just write the value, final value would be at 2 R naught minus initial value, we say that initial value at R naught. Now this value, if we see from the graph itself, now at 2 R naught, 2 R naught would be something here, it is the location 2 R naught. So the value of the potential at 2 R naught and the value of the potential at R naught, whether they are same or unsame, so they are not same. So that means this term would not be equal to 0. If this is not equal to 0, then potential would not be equal to 0, electrostatic potential energy. That means second option is also true. Now at R equals to R naught, electric field is discontinuous. Okay, now at R equals to R naught, in the C part, in the third case, now here just before R naught, to the left of R naught, okay, to the left of R naught, we can see electric field. We know electric field is given as, electric field is equals to minus dV by dr. Now in this diagram, just at R less than R naught, okay, what is V? V is constant, V is equals to constant. Okay, V is constant. Now V is constant, so we can say that our E would be what? Differentiation of a constant thing, that would be 0. That means electric field would be 0. Now if we take R greater than R naught, if we take R greater than R naught, that means for this portion just to the right of this R, sorry, just to the right of R, we are taking the distance R naught, that means the this R naught is the capital radius, that means radius. So here we see that potential variation is 1 by R, so we can say that it would be some constant time divided by R. Now if we take E value, so it would be minus C divided by R square. Now this value is not 0, because R would not be infinity, because it would be 0 when R is infinity. That means there is a discontinuity from 0 value to a certain value. That means this is a correct statement. It is a discontinuous, electric field is discontinuous. Now there will be no charge except R less than R naught. Okay, so it is given that there will be no charge, so we can just see in this case. Now if there is a if this is a conducting sphere, where will be the charge? Charge will be at the distance of what? R equals to R naught. So that means here the statement which is given that there will be no charge except at R less than R naught. That means inside this is wrong. Why? Because if this is a spherical cavity, then the charge would be residing exactly at r equals to r naught. So this statement is wrong. So what are the correct statement 1, 2 and 3? So what would be the correct option? A is the correct option. Hope you understood the solution. Thank you.
Hello everyone. Electric potential at a point xy, z in space is given here. It is V is equals to 4x square volt. Electric field at a point 1, 0, 2 is. So if we talk about the electric field at a point, it is equals to differential of potential with respect to x, partial differential, I cap, the same for y and the same for z. So if you see, the function is only in x. So the partial differential with respect to y and with respect to z, it will be 0. So it will be only in I cap direction, right? So you can differentiate it. The v is given, it is 4x square. So if you differentiate it both sides, I will write down del v by del x is equals to 8x. Now x is given here, it is 1. Right? If you see, it is 1, 0, 2. So x is 1. So I will write down the ex is equals to, if you write down this quantity as ex, so this ex is equals to 8. Right? Now I will write down the electric field at any point 1, 0, 2. It is minus 8 I cap volt per meter. And if you see here, we can write down it is. Thank you.
A point charge Q moves from point P to point S along the path PQRS in a uniform electric field E pointing parallel to the positive direction of x-axis. The coordinates of the point P, Q, R and S are a, b, 0, 2a, 0, 0, a, minus b, 0 and 0, 0, 0 respectively. The work done by the field in the above process is given by the expression. So work done is given by force into displacement. The force on the charge will be due to the electric field, so Q into E, and the displacement, since this is a conservative electric field is a conservative force, therefore the displacement will only depend, or the work done will only depend on the initial and the final positions, and therefore when we write the expression for displacement, we only need to bother about the coordinates of point P and point S. So the displacement will be root over the coordinates of point S, that is 0, 0, 0 minus coordinates of point P, that is a, b, 0, which is equal to Q into E root over a square plus b square. Therefore the work done is given by QE root over a square plus b square, which is option number 1.
ये हमें लाइन आप मतलब इलेक्ट्रिक फील्ड लाइन दे रखा है, ठीक ना, जिसके कांस्टेंट पोटेंशियल है, जैसे 50 वोल्ट है यहाँ पे 40 वोल्ट है, यहाँ पे 30 वोल्ट है, यहाँ पे 20 और यहाँ पे 10 वोल्ट है, और बोला है कि पॉइंट ए पे या पॉइंट बी पे या पॉइंट सी पे कहाँ पे इलेक्ट्रिक फील्ड जो है वो सबसे ग्रेटर होगा, ठीक है। तो देखो एक चीज़ है कि जहाँ पे भी इलेक्ट्रिक फील्ड्स लाइन जहाँ क्लोजर होंगी वहाँ पे इलेक्ट्रिक फील्ड का मैग्नीट्यूड ज़्यादा होता है। तो देखो यहाँ पे यहाँ से और यहाँ पे क्या है, बहुत ही दूर है, इसके कंपेयर में ये क्या है, थोड़ा सा पास है, और इसके कंपेयर में ये और थोड़ा पास है, और ये कितना इन सबसे मतलब क्लोजेस्ट जो है वो पॉइंट बी पे मिल रहा है। तो जहाँ पे भी इलेक्ट्रिक फील्ड लाइंस क्लोजर होंगे वहाँ पे इलेक्ट्रिक फील्ड का मैग्नीट्यूड सबसे ज़्यादा होगा। तो पॉइंट बी पे इलेक्ट्रिक फील्ड का मैग्नीट्यूड सबसे ज़्यादा होगा। ओके, इन दिस क्वेश्चन हमें स्टेटमेंट दे रखा है और बोला है कि ये ट्रू है या फॉल्स है। ओके, तो देखिए द स्टेटमेंट क्या है, द वर्क डन इन कैरिंग अ पॉइंट चार्ज फ्रॉम वन पॉइंट टू अनदर पॉइंट in an electrostatic field depend on द पाथ along विच द पॉइंट चार्ज इज कैरीड। ओके, तो अगर मान लो कि हम इस चीज़ को फिगर से समझें तो क्या होगा, फिगर से समझते हैं इसको। देखिए अगर यहाँ पे एक पॉइंट चार्ज है, ठीक है, क्या है यहाँ पे एक पॉइंट चार्ज है, इसको हम इस पॉइंट पे ले जा रहे हैं, मतलब कि इसको मैं ए मान लेता हूँ, इसको बी मान लेता हूँ, और इस पाथ से लेके जाते हैं, ठीक है। तो अगर वर्क डन W हो रहा है तो इस पाथ से भी लेके जाएंगे तो वर्क डन W ही होगा, या किसी और पाथ से भी ले जाएंगे तो वर्क डन W ही होगा, क्योंकि F जो होता है कूलम्ब फोर्स होता है वो 1/r² होता है, और ये क्या होता है, कंजर्वेटिव फील्ड होता है, मतलब कंजर्वेटिव इन नेचर। तो ऐसे फील्ड क्या होते हैं, पाथ इंडिपेंडेंट होते हैं, तो ये फॉल्स स्टेटमेंट है। ओके, क्या है फॉल्स स्टेटमेंट।
8 पॉइंट चार्ज है हमारा पास, ठीक है, 8 पॉइंट चार्ज है, उसको कहाँ रखा गया है, जैसे देख सकते हैं रखा गया है मतलब कॉर्नर्स, क्यूब के कॉर्नर में रखा गया है, ठीक है। डायग्राम में देख सकते हैं कि ना हर जगह रखा गया है, कोई प्लस क्यू है कोई माइनस क्यू है, हर जगह अपना अपना चार्ज रखा गया है। हाँ, क्वेश्चन में क्या बोल रहा है कि वर्क डन कितना लगेगा, ठीक है, इसको असेंबल करने में। तो इसका सबसे सिंपल तरीका इसको सॉल्व करने का क्या है कि ना वर्क डन कितना लगेगा ये असेंबल करने में ना, तो सबसे सिंपल तरीका इसको सॉल्व करने का ये है कि ना आप पोटेंशियल एनर्जी लिख दे ये सिस्टम का, मतलब जितने भी चार्ज रखे गए हैं ना, तो इसको रखने में कितने पोटेंशियल एनर्जी स्टोर किया, ठीक है, वो मेरा वर्क डन ही होगा। तो पोटेंशियल एनर्जी क्या होता है, के Q1 Q2 बाई आर, ठीक है। तो पहले तो देख लेते हैं कि ना यहाँ पे हर का अलग अलग आर है, मतलब किसी का डिस्टेंस a है, किसी का डिस्टेंस a/√2 है, तो ना हर का अपना अपना आर है। तो ना यहाँ पे टोटल 3 टाइप्स के आर है। जैसे ना यहाँ पे एक में तो a का डिस्टेंस है, जैसे ये सब मेरा a का डिस्टेंस हो गया, ठीक है। यहाँ से यहाँ तक का जो कॉर्नर्स होगा, किसी फेस का दो अपोजिट साइड्स का जो कॉर्नर होगा उसका कितना डिस्टेंस होता है, a√2 होता है, ठीक है। और पूरे क्यूब में दो एकदम एक्सट्रीम पॉइंट का डिस्टेंस कितना होता है, a√3 होता है। तो टोटल यहाँ पे 3 टाइप्स के डिस्टेंस है, मतलब a√3 होता है, ठीक है, ये आपको तो याद रखना ही है, ठीक है। तो ये टोटल यहाँ पे 3 टाइप्स के आर के वैल्यू है, ठीक है। तो हर के लिए हम लोग देखते हैं कि कितने कितने चार्ज रखे गए हैं, ठीक है, नंबर्स पता चलेंगे हमें कि ना उसको मल्टीप्लाई करने में आसानी होगा हमें। तो यहाँ पे देख सकते हैं कि ना ए हमारा एक ये हो गया, ठीक है, एक ये हो गया, 2 3 4, ए वाला मैं काउंट कर रहा हूँ, 5 6 7 8 9 और 10 और पीछे वाले 2 11 एंड 12। तो टोटल कितने हैं ए वाले नंबर्स कितने हो गए यहाँ पे 12। और सिमिलरली अगर हम देखें a√2 वाले, ठीक है, a√2 वाला कितना है यहाँ पे, तो देख सकते हैं कि ना किसी एक फेस को देखिए आप, तो किसी एक फेस को दो अपोजिट साइड को मिलाते हुए कितने होंगे, 2। एक फेस में कितने हो गए हमारे, एक फेस में हमारा इसको और इसको मिला देंगे तो 1, और इसको और इसको मिला देंगे तो 2। तो एक फेस में हमारा 2 हुआ है, ठीक है। तो टोटल कितने फेस होते हैं क्यूब में, टोटल 6 फेस होते हैं। तो 6 फेस को मल्टीप्लाई कर देंगे 2 से तो कितना होगा 12। a√2 भी हमारा कितना है यहाँ पे 12 है, ठीक है। और a√3 वाला कितना होगा यहाँ पे, a√3 वाला, तो a√3 मतलब कितना, मतलब दो एक्सट्रीम पॉइंट्स का डिस्टेंस। तो यहाँ से प्लस क्यू का डिस्टेंस इसमें, तो एक हमारा ये हो गया, एक हमारा ये हो गया, ठीक है, यहाँ से यहाँ तक का डिस्टेंस, और एक यहाँ से यहाँ तक का डिस्टेंस, फिर दूसरा ये तीसरा हमारा ये हो गया, और चौथा हमारा ये हो गया, ठीक है। ये तो ना ये हमारा टोटल 4 हो गया। a√3 वाले कितने यहाँ पे 4। तो बस इसी को हम लोग यूज करके हम लोग को क्या करना है, पोटेंशियल एनर्जी लिखना है। तो नेट पोटेंशियल एनर्जी जो होगा हमारा वो क्या होगा, k टाइम्स ऑफ, अब देख लेते हैं कि ना ए वाला में कौन कौन से चार्ज रखे गए हैं। तो ए वाला में देख सकते हैं कि -q और +q रखा गया है, ठीक है। तो यहाँ पे Q1 क्या हो जाएगा +q और -q, और Q2 हो जाएगा मेरा +q, ठीक है, डिवाइडेड बाई कितना डिस्टेंस है a, और कितने नंबर्स हैं, टोटल नंबर कितने हैं, नंबर है हमारे टोटल इस टाइप के चार्ज वाले 12। तो टोटल 12 से मल्टीप्लाई कर दूंगा। सिमिलरली a√2 के लिए कौन कौन से चार्ज हैं, a√2 के लिए देख सकते हैं यहाँ पे +q और +q, ठीक है, और यहाँ पे -q एंड -q। तो माइनस माइनस भी प्लस ही होता है इनडायरेक्टली। तो हम लोग यहाँ पे क्या करेंगे, q डिवाइडेड बाई कितना a√2 और मल्टीप्लाई कितना रहेगा हमारा, मल्टीप्लाई इसमें भी 12 रहेगा क्योंकि हम लोग निकाल रखा है कैसे 12 आया, ठीक है। अब हम लोग a√3 वाला देखते हैं। तो a√3 में कैसे कैसे चार्ज है, यहाँ पे +q तो वो मिल रहा है -q से, ठीक है, तो -q तो मतलब कि ना अपोजिट साइन वाले हैं, तो मतलब k इंटू क्यू इंटू माइनस क्यू, के माइनस क्यू इंटू क्यू डिवाइडेड बाई कितना था डिस्टेंस, a√3 का डिस्टेंस था, ठीक है। और कितने चार्ज है टोटल, नंबर कितने हैं टोटल 4। तो हम इसको सॉल्व करेंगे। अब हम लोग देख सकते हैं कि के क्यू स्क्वायर बाई ए हम लोग कॉमन निकाल जा सकता है, तो के क्यू स्क्वायर बाई ए हम लोग कॉमन निकाल लेते हैं, तो अंदर में क्या बचेगा, -12 प्लस 12/√2, 12/√2 प्लस -4/√3, 4/√3। तो हम लोग देख सकते हैं कि ना ये हमारा आ गया, ठीक है, ये मेरा आ गया पोटेंशियल एनर्जी, ठीक है। तो ये कितना हो जाएगा, इसको हम लोग डायरेक्ट कर सकते हैं, अगर डायरेक्ट कितना आ जाएगा सॉल्व करने से 5.824 इंटू के क्यू स्क्वायर बाई ए, ठीक है, के क्यू है ये, ठीक है, के क्यू स्क्वायर बाई ए, ठीक है। तो 5.824 हम के क्यू स्क्वायर बाई ए, कौन सा ऑप्शन हो जाएगा हमारा, ऑप्शन डी यहाँ पे करेक्ट आंसर होगा। के को हम लोग लिख सकते हैं 4πε0, ओके, तो ये तो हमको पता ही है। तो ये कितना हो जाएगा 5.824 क्यू स्क्वायर बाई 4πε0 ए हमारा इस क्वेश्चन में आंसर हो जाएगा।
Hello everyone, let us start with our question. In this question, what is given that there are two charges which are -2q and q, which are fixed at point which are having a coordinate -3q, -3, 0 and 3a, 0 respectively in the xy plane. We need to show that all the point in the xy where electric potential due to the two charges 0 lie on a circle. Okay, this is the first part. And the second part, if r is equals to x times a and the location of the center is ya, 0, we need to find what is x and what is y. Okay. So first of all, we represent the situation. Let's say this is our situation. This is our origin. This is our y-axis. This is our x-axis. This x and this is our y. So this is the charge which is placed. This -2q is placed at -3a, 0, and 2q is placed at 3a, 0. So this is the charge -2q, and this is the charge q. Now at any arbitrarily point p, which is having a coordinate x, y. What would be the potential, total potential? It would be due to this one. So we say that V would be equals to V1 plus V2. Okay. Now what would be equals to V1? What would be the value of the potential? So due to point charge, its value is very simple. K into Q divided by R. Okay. This is V. In general, this is our V, potential at any point. Okay. So due to V1, so we call this as to be 1 and this to be 2. So it would be V1, it would be Q1 divided by R1, and V2 would be equals to K Q2 divided by R2, where R1 and R2 are the distances. From where to where are the distances? From this location at the which we are having the charge to the location at we need to find the potential. Similarly, this would be our R1. Okay. So let's say this is our R1 and this is our R2. Now what would be the value of R1 and R2? From the figure itself, it is very clear that R1 would be equals to x. These are the coordinates. So we just write x minus 3a square plus y minus 0 square, that means y square. This would be our R1. What would be our R2? So it would be x minus of -3, that means plus 3. So x plus 3a square plus y minus 0, that means y square. Okay. Now what is the net value of potential which have been given? So we need to find what is the relationship between x and y, or we need to prove it is a circle when final total voltage is 0. So total voltage we put to be 0. What is the value of our charge due to potential, potential 1 due to charge q1? So it would be k into charge value is q divided by the distance r1. So r1 is x minus 3a square plus y square, and this is a square root. So we just take the power as 1 divided by 2. Now q2 charge is minus this q2 charge is minus 2q. So potential is a scalar quantity. We need to put the charge with this sign to 2q divided by R2, which is x plus 3a square plus y square, and whole to the power of what? It would be equals to 1 divided by 2. Now k and q, these are common from both the terms. So they would be cancelled, and then we can write this expression as this 2. If we take this to the other side, so it would be 2 divided by x plus 3a square. This is x plus 3a square plus y square whole to the power 1 divided by 2. This would be equals to 1 divided by, here it would be just 1 divided by this value of our R1, x minus 3a square plus y square to the power of 1 divided by 2. Okay. Now what we can do, we can just square these two terms. Okay. Now if we square both the terms, okay, and then we just on simplification we will get this result. So it would be just simply we need to square, okay, and we need to multiply this. If we square this would be 4. Then we can just multiply this term and this term here. Now on final simplification, our x square plus y square minus 10ax plus 9a square, this would come upon simplification, just 1 or 2 step in between. Okay, now if we need to make the perfect square, so we can just need to just incorporate this term. So it would be x square. So here it is negative, so we write minus 5a square. So this is, sorry, this would be x. This is how we make the perfect square. So x minus 5a square, that means x, the sign which is coming here with the coefficient of x, we write the sign, and the coefficient of x we need to divide it by 2. So it was 10a, we write 5a. Then minus, what is the term which we have written? We need to subtract the square of this term. This is how we make the perfect square. Likewise in the quadratic equation itself, plus y square. So this is the term which are coming from here. These are the adjusted term, plus y square plus 9a square. This would be equals to 0. So we can say that x minus 5a square plus y square. So this would be minus 25a square. This is 16a square. So what would be the net result? It would be minus 16a square. So if we send it to the other side, it would be 16a square. Now this is the equation of circle. This is the equation of circle. How do we know? Because the standard equation of circle is x minus alpha square plus y minus beta square. This would be equals to r square, where alpha and beta are the coordinate of the center. We can just compare. Then alpha would turn out to be 5a, beta would turn out to be 0, and r square would be 16a. So r would be equals to 4a. So this is the equation of circle. Now if we compare, r is equals to x times alpha. Now r is given as to be x times of alpha, and r we have calculated 4a. This would imply that our x value is coming out to be 4. Now the coordinate of center, this is ya. So coordinate of center in our case, it is equals to alpha, x coordinate is alpha. So we say that our alpha would be equals to, which is given as to be, this is ya. So y times of a, this is 5a. This would imply that our y value would be equals to what? It would be equals to 5. So this is what we need to find these values, the values of x, the values of y, and prove that it is a circle. Hope you understood the solution. Thank you.
Everyone, here one question is given. So let's see what question says. 3-point charges Q, 2Q and 8Q are placed on a 9 centimeter long straight line. So we have to find the positions where the charges should be placed such that the potential energy of the system is minimum. Okay, first point. And in the secondary situation, what is the electric field at the charge small q due to the other two charges? Okay, so as you can see in this diagram here, here 3 charges are placed. Okay, so first we have to check that how it is placed. See, the potential energy is basically, I'm just writing down its formula, that is U is equals to K Q1 Q2 upon R. Okay, so see in this equation we can see two charges are given. So for the minimum potential, okay, for the minimum energy, okay, how we can arrange these charges? See, Q is in the between 2Q and 8Q. So for the minimum energy, it should be like that the bigger charges, that is 2Q and 8Q, it should be away from the center. Okay, that should be away from the center. So that's why Q is in between, the small charges in between, and 2Q and 8Q is away from the center. Okay, so that is if it is x, so that is 9 minus x, because that complete is 9 centimeter long straight line. Okay, so first calculate your potential energy. So for potential energy, U is equals to K dot, suppose for 2Q, so 2Q dot Q divided by X plus K dot 2q dot with 8q that is divided by, and that complete is 9 centimeter. Okay, so 9 plus, now one more combination is there, q and 8q. Okay, so k dot q dot 8q divided by 9 minus x. Three combinations are there. Okay, now you can solve these combinations. So u is equals to, you can take q, k and q outside the bracket, and in the bracket we have 2 by x plus 16 by 9 plus 8 divided by 9 minus x. Okay, now you can use this term which is in bracket as a. Okay, so our a is equals to, now you can solve this. Okay, you can solve it, that is 2 by x plus 16 by 9 plus 8 9 minus x. Okay, now for the minimum potential energy, it should be minimum. Okay, value is minimum. Okay, so a should be minimum. For the minimum potential energy, a should be minimum. So you can just differentiate it with respect to x divided by dx. So after differentiating, minus 2 by x square, this term is 0 because there is no value of x, and this is in 8 by 9 minus x whole square is equals to 0. So after solving this, we get value of x, that is equals to 3 centimeter. Okay, value of x, that is equals to 3 centimeter. Value of position is x is equals to 3 centimeter. Okay, now in the second situation, what is the electric field? In the second situation, we have what is the electric field at the charge q, at this charge. Okay, so you can see both are positive charges here. 2q by 2q, the electric field is in this direction. Okay, by 8q, the electric field is in this direction. Okay, and you have to find the electric field at point q. Okay, so let's find that first is electric field. In the second case, we have to find electric field. First is due to 2q. Okay, see, this is charge q. Okay, one is in this direction electric field, and one is positive and one is negative, you can take. Okay, so that is kq by r square. Okay, and that is k into q is our 2q divided by 3 whole square. Okay, take it positive. Okay, now E, energy, electric field, basically due to 8q. Okay, so that is k into 8q divided by, now the value of r is 6 whole square. Okay, take it negative because this direction is opposite. Okay, now the E net is equals to k 2q by 9 minus k, that is 8 kq by 36. Okay, so 8 nines are, so now that is basically 2 and 9. So 2kq by 9 minus 2kq by 9, and that is 0. So the net electric field is 0.
Hello everyone, let's start. This question says two fixed equal positive charges equal each of magnitude 5 into 10 raised to 5 minus 5 coulomb are located at the points A and B separated by a distance of 6 meters. So you can look at in the figure. There are two equal charges fixed. There is distance between them is 6 meters. Okay, and each plus q is equal to what? 5 into 10 raised to minus 5 coulomb. This as well is plus 5 into 10 raised to minus 5 coulombs. And what is next? An equal and opposite charge. An equal and opposite charge. Where is it? In the figure, an equal and opposite charge means the magnitude of charge is 5 into 10 raised to minus 5 coulomb, but it is of negative charge, means this negative q is equal to is minus 5q, minus 5 into 10 raised to minus 5q. So what does it say? What does the question say? That this charge is moving, this opposite charge moves towards them along the line COD, the perpendicular bisector of AB. Bisector means it was the distance between these two positive charges was 6 meter. Bisector means it is cutting half. So the distance from O to A is 3 meters and from O to B is also 3 meters. Okay. Now the moving charge, when it reaches the point C at a distance of 4 meter from O. Now what does it say? That C is at distance 4 centimeter from O. So this distance is 4 meter. Okay, these are in meters. 4 meter has a kinetic energy of 4 joules. When the moving charge, when it reaches point C, it has kinetic energy 4 joules. Calculate the distance of the farthest point which negative charge will reach when returning towards C. See, why would it return towards C? At this point it has some kinetic energy. It will keep going and it will be affected with some potential energy present due to these charges. These charges will be releasing some electric field due to which it will have some potential, and it has kinetic energy also. So it will keep going to a point where its kinetic energy becomes zero and potential energy becomes maximum. At this point it has some potential energy plus some kinetic energy, and it will keep moving until its kinetic energy becomes to zero, and it will stop. For example, in the question says that it stops at point D. So at this point its kinetic energy will be zero, but the potential energy will be maximum, because you know total energy never can be dissipated. Conservation of law of energy, it says that energy can neither be destroyed nor be created. It can just transform from one form to another. Here some value of potential energy was there and some value of kinetic energy was there. So as it will keep going forward, its kinetic energy will turns out to zero, and that much energy will start adding up into potential energy, because total energy has to be the same. Yes, I hope you understand till here. Total energy remain conserved. You have to remember this thing. Total energy is conserved. Now we will do the same thing by using the formula. Now see, we will start by taking this whole system, because you know for a isolated system it's possible. If you are taking only minus q into consideration here, for its the external force would be due to this charge and due to this charge. In that case total energy is conserved will not apply. Why? Because it would be just an isolated system and these will be external to this. So what will we do is, we'll take all the charges at the whole system and it will be isolated from any outer force or field, because there is no another field. So for a isolated system this energy conservation is applied. Yes, because if some force is applied on some external forces there, then energy can be added, right? But conserved means it will transfer from one form to another only when the system is isolated. So that's why we'll take this whole system as one, because there is no external force in this whole system. So total energy conservation will apply to this field, and we will do it by formula wise. We will write the potential energies of all the charges with respect to each other, and if some kinetic energy is there, we will add that too. Now let's write the kinetic energy and potential energies of the whole system. Okay, so first of all, let's see what is the distance between this. If we are taking potential energy, taking out potential energy, it will be this distance and this distance. Potential energy of positive Q with respect to plus Q at A. First of all, we'll write that one. Plus Q into minus Q. Yes. Upon into K, that is 1 upon 4 pi epsilon. And distance between minus Q and plus Q at A is 3 and 4 is there. So this will be 5 meters here. It will be 5 meters by Pythagoras theorem, and similarly here as well. So here it will be 5 square. You must know the formula for potential energy. Similarly for the charge at B, the potential due to charge at B would be minus Q again into plus Q into K on 5 square. And now the potential energy of these two charges, those positive charges, it will be simply, because we are taking for the whole system, you would keep that in mind, we are taking out the total energy for the whole system. So distance between these two positive charges is 6. So this is your total energy for the system in this position when charge is at Q. When charge minus Q is at C, this is the total energy. Okay, total energy of system. Okay, it's of system when charge minus Q is at C. Now total energy of system when charge minus Q is at D. See, at this point what will happen? See, at the point C there is some potential energy as well. We forgot to write that, right? So add the potential energy also. How much it is? It's 4 joules. So you have to add 4 here. Now come at point D. At point D the distance would be how much? We'll assume this as x. So this distance would be x square plus 3 square under root. This will also be like this. So x square plus 3 square means 9. So this will be your distance. So just simply write the equations of total energy here. Now the distance in place of 5 we just put minus q square minus q square x square plus 9. The square of it will be, the root will be removed again, minus q, oh the square should be here only, x square plus 9, and between two positive charge it will be again the same, because they are not changing, their position is not changing. This is between two positive charges, this one kq square divided by 6 square, plus kinetic energy is 0 here. For minus q the kinetic energy is 0. So this is your final expression for the final energy when charge is at D. Now according to the total energy conservation, these two energies should be equal to each other. Yes, because there is no external force applied on this. This is an isolated system, so its total energy should be conserved. So we will equate these two equations. and we'll find out the distance of point D, that is x. Let's just equate these two equations. We will add these up and it will come as minus 2k for equation number 1. This is, let's say, this is equation number 1, this is equation number 2. So we are writing equation number 1 here. 2k minus 2k q square upon 5 square plus kq square upon 6 square plus 4 is equal to minus 2k q square upon x square plus 9 plus kq square by 6. Kq square by 6 square will be cancelled out, and 2 will cancel out. It will remain, this one will remain 2, and this will be cancelled out. So we will be left with remaining would be this plus 2. You can easily solve it now. Minus kq square plus 2 into 5 square. 5 square. You'll put the value of k and q square, and q, values of q you already know, that is 5 into 10 raised to minus 5 coulombs. And you can easily find the value of x. If you will solve it, you will get the value of x as, thank you, 8.48 meters.